This is a circle. It has a radius of 5 and it goes through the origin. So it does something like that. And then this is going to be a straight line. If we want to rearrange this, I can say that y is equal to 3x minus 13, so plus 13. So it must cross somewhere above 5 and it's got a gradient of 3. So it's going to do something like that. And I haven't drawn this very accurately, but we can see that there's going to be two collisions here. Now there must be at least one solution. So at worst case, it's going to describe a tangent and only have one solution. If you try to solve simultaneous equations where there isn't a solution where they cross, you get some really weird results. It's best to solve this by substitution because the y's in both of these are the same, the x's in both of these are the same. But at the moment we've got two different variables. If I take just this equation here, y, that could equal to 16, meaning that x is equal to 1. That gives us 13. But then y could be 19, and then x could be 2. And you can see the issue here. We've got no bounds on what x and y could be at the moment. But it also has to satisfy this equation. And obviously 16 squared is well above 25, so that's not going to work. So this y here is the same as that y there, but it's equal to 3x plus 13. So I can actually take this 3x plus 13 and replace it with that y. This is called substitution. And I get that x squared plus 3x plus 13 all squared is equal to 25. And we're going to simplify as we go along, so either square that bracket, where the first term I get 9x squared, double the product, 3 times 13, that's 39. If I double that, I get 78, so that's 78x, plus 13 squared, which is 169. And of course, if you don't know these and you can't do it mentally, then do it written down, use written formal methods, that'll help you through. X squared plus all of that is equal to 25. And again, it's good practice to put it in brackets to begin with, just in case. In total here we have 10x squared. It's an uncalculated paper, it's a quadratic, which we need to solve. We're probably going to have to factorise. I'm going to bring this 25 across, so it's all equal to 0. 169 minus 25, that's 144. That's all equal to 0. But if I try to factorise from this point here, there's a bit of an issue. Because do we have 10x in one bracket, x in the other? Or do we have 5x and 2x? Because either of these is going to expand to give us 10x squared. And also this is going to be quite a difficult problem. I'm going to have to list out all the factors of 144. But fortunately we can simplify this, because all of these are even, including 0. I can divide all of this by 2. So over half 10x squared, halving the 78. I already know it's going to be 39 because I doubled that earlier. Half of 144, that's 72, and half of 0 is just 0. And this time, I know for certain it's just going to be 5x in one bracket, x in the other. I know that both of these signs are going to be positive, because both of these are positive. Consider that when I expand this out, I'm going to have 5x times by x, 5x times by whatever that is, this times by x. So in order to get positive values here, when I have this value times that value, that's the only way I'm going to have a positive. Unless both of them are negative, but if both of them are negative, I'm not going to get positive here. There's various different ways you can solve a quadratic when you haven't got a coefficient of 1 as your x squared. My preferred method is listing out the factors of 72 and putting them into pairs. So I start with 1 and 72. There's no way I can put these in, because if I put 72 here and 1 here, if I start to expand this out, I get 5x squared. 5x times 1, that's 5x. But then I'm going to have 72 times x, and that's just going to be well above 39. And obviously 5 times 72, that's going to be even worse. So we can exclude that. Next factor is 2, and that'll be times by 36. Now this is promising because this is quite close to 39. And obviously don't want to do with 5 times 36. So I'm going to put a 36 here and a 2 here. I don't really want to do this in our head, but we can write it out just to be a bit more fluent and confident with what we're doing to begin with. 5x times 2 is 10x. Then 36 times x, we're going to get 36x, which is going to push us over 39x, because we're adding 10x to that. We can exclude these. Next up, 3. That's divisible into 72, and that goes 24 times. 24 obviously has to go in the left-hand side, 3 would have to go in the right. Now, 5x times 3, that's 15x. 24 times x, that's 24x. And this works. 5x times x gives us 5x squared. Then timesing out and going to get 39x. And then 24 times 3, that's 72. So start with your factors, list them in pairs, and trial and error. See which ones work. And both of these brackets times together, that's still equal to 0. This tells us that either one of these has to be equal to 0, because this here is going to give us a number. This here is going to give us a number. Now the only way we can times two numbers together and it equals to 0 is if one of these numbers is 0, or both of them. But they can't both be 0, in this case anyway. So either 5x plus 24 is equal to 0, or x plus 3 is equal to 0. X plus 3, if that's equal to 0, x is equal to minus 3. And we can just tell straight away that, because if we start with minus 3 and we add 3, we get 0. But better technique is rearranging. So we minus 3 from both sides, that's what we're going to get. Now this is the technique we have to do here. We have to take away the 24 to begin with, and then divide by 5. So I minus 24 from both sides, and then divide by that 5. We got our x values. Now to fully solve this, we need to find the y values. Unfortunately, we got a nice equation right at the top which we can use, and that's that y is equal to 3x plus 13. 3 times minus 3, because I'm substituting in x equals minus 3 into this, is minus 9. Then adding 13 to that, when we're doing a negative and we're adding the positive, we can consider it the other way around. So 13 minus 9, we get that y is equal to 4. This one's a little trickier, so I'd probably write down how we'd approach this one. And we have 3 times minus 24 over 5, add 13. 3 times 24, we should already know that from our list of factors earlier. That was 72. So this is going to give us minus 72 over 5 plus 13. Adding fractions, we need the denominators to be the same. So I'm going to convert this into fifths. Because 72 doesn't divide by 5, we can't simplify that down. It's prime, no other way of simplifying. Now 5 fifths is equal to 1. So for every 1 we have, we're going to have 5 fifths. We have 13, so we're going to have 13 lots of 5 fifths. 13 times 5 is 65. We're at something quite negative, and we're adding, so we're getting less negative. So in fact for this one, I can do 72 minus 65, and then it's going to be negative. To see where I can do that, if I have minus 72 and I'm adding 65, I can actually bring out minus 1 as a factor. So minus 1 lots of 72 minus 65, that's going to give me the same result, because when I expand this bracket out, I haven't changed this. Then if I count up from 65 to 72, that's 7. So it must be minus 7. And that must be our y solution. The second y solution is that y is equal to minus 7 over 5. Now obviously I haven't presented this very well. In the exam I'd write that up there, just to make it easy for the examiner, for one thing. They don't want to be wading through a whole lot of working out. They might miss certain things if you're quite messy with your presentation. But secondly, for when you come back and check. But later on in the paper, you're going through your thought process again, you're going to get lost yourself if you haven't presented this well.